All right, guys. When I first saw this section, I was like, ooh. But I think that you're going to be fine as long as you use your graphing calculators to help you. So let me pull that up. Okay, so to start with, uh, these first couple are just asking you to plot some points and then to graph the equation. So the thing to remember is that when it's just an r equals some number, that means that you want all points that have the radius of 3. So it's literally just going to be plotting some points around the circle. And then now it's asking you to connect these points that they've already plotted into a graph. So I really don't think that you'll have any trouble with that. When it's just theta equals an angle, then what you're going to do is open up to that angle and you're going to draw a straight line through that angle and then all the way down to the opposite side. Wait, this is the points, I think. Plot points. So you would just put some points here. And then here, oh wait, maybe it's both on the same one. I'm not sure. You'll know when you open it up on Alex. Okay, this one, plot points, 7 cosine of theta. And so a couple of ways you can do this. I don't know if it'll be, like, I personally would just be like, okay, if theta equals 0, what happens? Cosine of 0 is 1, so that would be 7. So I know that my first point would be 7, 0. Then I would say, okay, well, what happens when theta is 90? Then it would be r7 times the cosine of 90. The cosine of 90 is 0. So this would be 0. That point would be here. And I would continue this. What if it's 30? Well, that'd be 7 cosine of 30. So 7 square root of 3 over 2, approximately 60.6 degrees. And so, not 60.6 degrees, approximately 6.06. So at 30 degrees, which would be 15, 30, 45 here, I would go out to 6.06. So something like that. And so you'd continue this process. At 45, it's about 4.95. Now, I think we might be able to, I'm going to check. So we're zooming 7 here. Okay, so here's what we've got. Now, keep in mind the graphing calculator probably distorts it a little bit because it's not square, and plus I've got the screen all messed up. But if we go to our table, okay, so right now you'll notice we are in radians. And if we go to our, let me check something here. If we would go to degrees, yeah, it won't work. So we'll make our change in table. Yeah, I don't think. Let's try, I should have done this before I got on video, I'm sorry. Okay, that might work. Okay, so if you go to table set, which is above window, start your table at 0 and make your change in table pi over 6, which is 30 degrees. And you have to enter it like that. Then go to your table. Every increment that you see is by 30 degrees. So at 30 degrees, the value is 6.06, which is what we got over here as well. At 45 degrees, which would be, this isn't going to do 45, this will be do 60. So I guess you could do the table by 15s. But you get the idea. At 90 degrees, you have 0. So you could use this to get yourself some points to plot. But I personally just think it's easier to figure it out, to be honest. Okay, and so, let's see, 45. I did 60, so I got 3.5, 60 degrees. And then I got negative 4.95, 135 degrees. And I just kept going until I had enough points that I could get my circle. So something like this. And then it was same ones on the bottom. Okay, this one already has the points there, so you just have to, same here, you're going to do the same thing. Now this is going to end up being a line through 4. And this is a circle with radius 6, so you guys get that. There's the points. And this one is a straight line that through negative 2. Okay, so then we're here to 7. So this one is testing for symmetry. And the thing that with polar graphs, you can't just rely on how the graph looks to determine if it's symmetrical. You actually have to test the equations. And so a couple of the things that we need to remember when we're doing our, when we're plugging in negatives here. The cosine of a negative angle is the same as the cosine of that positive angle. But the sine of a negative angle is the negative sine of the angle. So if you remember, even in odd functions, the cosine, you lose your negative, but the sine, you keep your negative. And then the other thing is the sine of pi minus theta is equal to just the sine of theta. I don't know why this thing does. Every single time I'm recording a video for you, it's all funky. The cosine of 90 or 180 minus theta is equal to the negative cosine of that theta. So the way that we test is, and it does tell you right in the direction, so it's not like you even have to remember it. It tells you in the directions. We're going to test for 3 things. If it's symmetrical about the polar axis, which the polar axis is the x-axis, and you do that by replacing theta with negative theta, simplifying, and see if the result equals the same equation. Then you're going to test for symmetry about the line theta equals pi over 2. And you do that by replacing theta with pi minus theta. And then about the pole. So the line theta equals 90 is so this is, I'm stumbling. This is x-axis symmetry. This is y-axis symmetry. And this is origin symmetry if you're relating it back to our rectangular situations. Okay, so take our function, replace theta with negative theta, see what happens. Well, for cosine, if you have a negative on your theta, it's the same as not having it. So that would be 5 cosine of 2 theta. This matches this, so we can say that it is. And now we go down here, do the same thing. So r equals 5 cosine 2, and we put in pi minus theta. Well, if you look back here, when you have the cosine of 90 minus an angle, it's the same as, oh wait, jump back. We've got to distribute this. 2 pi minus 2 theta. All right, so now if we think about this, if we take 2 pi and subtract 2 theta, it's going to be the same exact angle. 2 pi plus or minus anything gives you the same exact angle. So this is essentially this, which is the same, so it is symmetric. Okay, now we go to this one, and on this one replace negative r. So it's going to be negative r equals 5 cosine of 2 theta. So in order to compare these, we would need to solve this for r so that we have the same initial start, or the same left side. And so this is what we'd end up with. And since those aren't the same, you would say not necessarily. And that's how you do those. So if we think about it, anytime we're doing the polar axis, if we have a cosine function, the negative is going to kind of disappear. But if we have a sine function, the negative stays. So this would be, which means I would pull that negative out front. And so now they don't match. Okay. Now for this one, now there's no number in front here like there was on the problem before. So we can use those rules, and 180 minus theta is the same as just sine theta. They match, so it is. And then this one, obviously, you're going to have a negative here and a negative here, so that'd be a no. So we're essentially doing the same thing, but they're just asking the answer in a different way. So if it is, then we would circle this, but if it is not, then we would say it's inconclusive. So this is a sine function, and we all know that the sign for a negative theta, we keep the negative, or I mean, with sine, we keep our negative, so it's not going to be the same. So that one's going to be inconclusive. This one, the sine of theta is the same as the sine of theta minus 90, so that one would mean that it shows that it is symmetric. And for the pole, we would basically multiply this by -1 or divide it by -1, same thing. So you'd end up with -4 over 4 plus sine of theta, not the same, so inconclusive. All right, you kind of get the idea. This one's inconclusive, this one's inconclusive, and this one's inconclusive, which kind of makes sense because there's no trig function. So any alteration is going to make a change. Okay, so now we are to graphing. And I did look on Alex because I wanted to kind of see how they make you graph it. It's actually not. If you have your graphing calculator, it'll be fine. Just plug in the function. And then match the shape of the graph up with the option that it gives you. Once you click on the option for the shape of the graph, it'll ask you to plot basically 2 points. So you are going to need to either look at the table, but it's probably easier just to look here. In this particular case, it asked to do the bottom end of the graph, like this part of it. So you had to place it at 4, and then it wanted to know where like this part would be, and that's at 0, 0. And so all of those are, you just plug them in the calculator, and then you match them up with the shape and plot a couple points. So I feel super confident that you'll be okay with that.